This on firmly. So what I want to go over with you first is a little bit of what the rest of the semester is. We've just got 2 chapters, and then we are taking what's called the final exam. The final exam is not comprehensive in here. It just covers chapters 8 and 9. The understanding is that to do chapters 8 and 9, you have to understand 1 through 7, right? Because if you don't, you won't be able to do these 2. They do get more complicated. These are probably the most complicated chapters that we have. The problems, mostly word problems. You'll have more problems on this test than definitions, perhaps. You will have time to work it, don't worry. But I do want to point out some things that are going to help you as you start studying for this test, and you should start now so that you're really prepared. And this is the page that's in your guided notes that says Chapter 8 and 9 notes. Should be at the beginning of Module 4. This one points out, and I put it all in a nutshell on this page for you. This is sort of defining or distinguishing where the differences and the types of problems are. And really what we've got here is confidence intervals. This is Chapter 8, if you want to just note that. And really this is Chapter 8 too. We cover sample size a bit in Chapter 8. And hypothesis testing is Chapter 9. But what you have to remember about the difference, major difference in these chapters and the ones that came in 6 and 7, is that now we're going to be dealing with population standard deviation, and sometimes we won't have that. We'll have a sample standard deviation. So that changes things, and it introduces a new table for us, and it's called the T-table. The T-table, also in your book, does not look anything like the Z-table, although its function is the same. And it introduces something called a column called degrees of freedom, which is actually the sample size minus 1. So it's not hard to get to degrees of freedom. But when you look at this particular T-table, and there are a lot of different versions of it, when you look at this one that we're using for confidence intervals, and basically I think for hypothesis testing too, you're going to use this top row to distinguish which column you're interested in, okay? You'll find degrees of freedom, which will be, based on sample size, and then you're going to look at the confidence level that you are interested in. How confident do we want to be that this is going to be, our sample that we take is going to be in this range. And so that's the number. This level for one-tail and two-tail test to me is too confusing. I would just almost mark those out and just basically go on that top column. I'll show you how to do it with your calculator too, if you're interested, and it basically is the same way you were doing finding z-scores. You go to the distribution menu, and then you go look for inverse t, and then you have to enter the alpha divided by 2 as the first parameter, and the second one is degrees of freedom. So I made those notes just in case that helps you, in case you're interested in finding these numbers or these scores on your calculator, okay? So you'll be doing both things. You'll be looking for the t-scores. Sometimes we'll have to use t, and sometimes we'll have to use z. Your job is to figure out which one is which. When do you have to use which score? That's why I made this paper, okay? This tells you that if you know the population standard deviation, you use the z-table. If you don't know it and you know the sample standard deviation, you're going to use the t-table, unless it's a proportion problem, which always uses the z-table, okay? That's it in a nutshell. So you'll have to figure out, and there's the basic formulas that go, confidence interval formulas, and what they do is they just replace z with t, and you have a new way to calculate the standard deviations based on what type of problem you have. You have to do an adjusted standard deviation, listen, for every problem that we're going to hit in these 2 chapters, okay? We're not going to be using just the plain standard deviation again. We did that in 6 and 7, but we don't now, okay? All right, so that's it in a nutshell. Basically, we'll talk about hypothesis testing and the 3 types of test when we get to the next chapter. All right, ready? Oh, one more thing. This page that's also in your guided notes, there's a review. I think it's got 101 problems on it at the very back of the 104, at the very back of your guided notes book, and it's the final exam practice questions, and it's a really good idea to work those problems. But when you're looking at these problems, you are looking at, these are confidence interval problems, these are sample size problems, and these are hypothesis test problems. Remember, this is chapter 9. We're not hitting that today. But these, if you want to know, you want to work some of each problem, it's a really good idea to say, okay, This one has a population standard deviation. This one has a sample. This is a proportion problem. Make sure you're hitting all the different types of problems, okay? And you understand the differences in the types of problems. When you got the sample size problem, you're going to have population standard deviation, or you will have a proportion problem. It's not really going to be anything that has the sample standard deviation, because the whole idea is how big a sample do I need to take. So we haven't taken the sample yet, right? We're trying to figure out how many. All right, so that's your notes that you need to be familiar with, I think. Let's start in Chapter 8 and start working these problems. This one says, suppose I want to construct a 95% confidence interval for a sample mean, and I'm going to use the population standard deviation. It's going to be known. So, and then I'm going to determine the z-value that we used to construct such a confidence interval and round it to 2 decimal places. Now, what this one is telling us basically is that, and I wanted to draw it here for you, but every time you get one of these word problems, start writing stuff down like, what did they tell you? Well, the confidence level. Now, that's not the confidence interval. That's the level of confidence they want us to have. They gave it to us as 95%. I'm going to represent it as a decimal. It's 0.95. Once I know the confidence level, these things I also know, and I will go ahead and write them down as soon as I know them. I know alpha. Alpha is 1 minus the confidence level, okay? It's 1 minus 0.95, or it is 0.05. I can then get alpha divided by 2, which is I take 0.05. I'm not going to always write this for you, but I will on the first one. Divided by 2, and it's going to be 0.025. Once I know alpha divided by 2, I can come up with the z-score or the t-score that I need, okay? This says population standard deviation is known. That tells me z-table. That's what tells me z-table, okay? So I go to my z-table and I say, well, the area under the curve that I'm interested in is 0.025. Now, how do I know that? Well, I'm going to draw it for you just this one time because I want you to see it, okay? Let's pretend this is our curve, that's our z-table, and underneath it would be our sample means, and we really don't know what the sample means are, so that line's going to be blank for this particular example, okay? But what they're saying is they want us to be 95% confident that the sample mean that we draw, the population mean is going to be between 2 numbers. Well, it's going to be the same distance on both sides, and they want this to be a 95% area. Therefore, this area is going to be the 0.05 that's left over, isn't it? Divided by 2. That's why we're looking up a z-score that corresponds to these limits that we've set ourselves. The limits are based on the confidence level. So we're looking up a z-score and we find alpha divided by 2, right? And that's the area in the left tail. So we're going to look up 0.025 on that z-table. I told you this is abstract. A lot of this is abstract thinking for you, but maybe you'll do enough problems that it won't be. Now listen, on this next test, you never need the positive side of the z-table. You only need the negative side. You're always going to look everything up on the negative side, and you're just going to take the positive score, okay? So I'm going to go to the negative side, and I'm going to go 0.025. There it is right here. And it's 1.96. Well, it's negative 1.96. But because of that, I know that this is a positive 1.96. They match, don't they? So this is how it's actually, you know, set up. What is this area right here? Well, it's alpha divided by 2. Okay? Alpha divided by 2 is what we call it. All right, so once you have your confidence level, how did I get alpha divided by, how did I go down to all the way of a z? And then we only use the positive z for our calculation, so you don't have to worry about the negative. How did I get all the way from, they gave me a confidence level of 95%, I need a z-score of 1.96, it's this way. If they give you the confidence level, you know the z-score, okay? Or the t-score if it's a sample. You can get it. This is exactly how you do it. So that's all it asks you is, you know, find the z-value that would be used, 2 decimal places. We just looked it up. Any questions? And you always use the positive z. You good? All right, let's go and look at another one. This says we have a confidence interval. It has a range of likely values for the average height of all American adult men. Well, this is the range, 74 to 78 inches. That's my range. We want a point estimate. We want a sample mean. That's always the point estimate. Listen to me. What's always the point estimate? The sample mean or the sample proportion, whatever it happens to be that you're working with. So, and then we want a margin of error to get that confidence interval. In other words, they gave you the solution and they want you to work backwards. Well, I didn't draw you a curve here, but I wish I had, because this is what it would look like, okay? This would be the z, and this would be underneath it, the sample mean. And what is that sample mean? Well, we don't know what the sample mean is. That's the unknown. Usually it's not the unknown, but this time it is. So what it does tell us, though, is that the limits are 74 and 78, and we know that those are equal distance from the sample mean. What's the sample mean? $74 blank 78. What's the blank? Yeah, 76. I mean, it's almost a common sense problem, isn't it? And really, that's this one. And so all they're saying is, how would you get that sample mean from what they would told you? Well, you take the limits, 74 plus 78, wouldn't you? And divide them by 2, and you come up with 76, right? But you can just see it when I draw it, can't you? I mean, can't you see it? And so what is, they're saying, what's the point estimate? Well, the point estimate's always the sample mean. The sample mean's 76 in this one. What's the margin of error? Well, the margin of error is always what we go plus or minus the mean, right? Well, what's the distance between 76 and 74? 2. What's the distance between 76 and 78? Come on, quick. 2, thank you. And that means our margin of error is equal to 2 on that one. Now, I understand that this is not the normal way you're given problems to work. This is just seeing if you understand the concepts. If they gave you those confidence intervals, could you get back to the sample mean? Yeah, it's going to be halfway between them. Could you get to the margin of error? Yeah, it's going to be whatever I add or subtract to the sample mean to get back to the confidence level interval, okay? Backwards working is what that problem is. Okay, next problem. Stop me if I'm going too fast, but you guys look like you're following, so, okay. A city official wants to estimate the mean age of all residents of Fort Pierce. The standard deviation, now look, start doing what I'm going to do. The standard deviation of the ages of all residents, standard deviation of all is a population standard deviation, and that's 17. You know the symbol. Make sure you know that means population, because this is not always going to be the case. You're not always going to have it in these two chapters, okay? We want the sample size so that the margin of error of the estimate for there's my confidence level, right? My confidence level is going to be 0.96. Confidence interval is 0.96. And we want that margin of error to be at most 1.4. Okay, so that's what they gave us. Now here's my formula. I go and I say, okay, I got to have a formula for n, because n is not known, and n is what they asked me for. And my formula in my formula sheet says n is equal to z squared times the standard deviation of the population squared divided by the margin of error squared. All right, I know this one. Do I know z? Well, yeah, they gave me the confidence level. I can get z, right? Here's how I do it. Confidence level is 96. Alpha is equal to 0.04. Everybody knows how I got there, right? What's alpha divided by 2? Well, can you divide 0.04 by 2? 0.02, right? Okay, how do I get z? Well, if I know alpha divided by 2, remember, it's the tail. All I have to do is go to my z table. Why z? Because look, they gave me the population standard deviation, and I look up 0.02. Remember, only using the negative side, 0.02, 0.02, 0.02. Well, as close as I'm going to get probably here is 2.05. That's the one I'm going to use. Everybody okay with that if I just go 2.05? Oh, yeah. So it said negative 2.05, but I know that I only use the positive z for these two chapters, right? So I've got my z-score. I have my z-score. I have my standard deviation. I have the margin of error. Now it's simply plug these in. 2.05 squared times standard deviation of 17 squared divided by margin of error of 1.4 squared. You can do that in your calculator in just one step. Hopefully some of you are working it because I've already done it. And I came up with, tell me if I'm wrong, okay, because I'm counting on you guys today. I come up with 619.6. Is that what you get? Okay, now look, normally, listen carefully, that would round, if I said round, you would go up. But for sample size, we do this. Put an arrow beside it and point up, because no matter what that decimal is, you're going to go up to the next number. If it was 619.2, you would still go up to 620. Why? Because you cannot take a fraction of a person as a sample, and you have to have at least this many. So if it said 619.2, I can't find 0.2 of a person, I'm going to have to go up and interview a whole person, right? Go up to the next one, don't round the thing. Are you listening to me? Because that's one of the most commonly missed questions on the next test, is rounding down that sample size. You don't round it, you simply bump it up to the next whole number. Have you all heard me? Everybody nod, okay? Because I will tell you that's one of the most commonly missed questions, okay? All right, so we have a sample size of 620. We have to survey at least 620. All right, next question. We have a researcher wants to estimate the mean weight of all adult female alligators in the Everglades. And the mean weight of a random sample of 129 adult female alligators from the Everglades was found to be 206 pounds. Now, I'm going to start jotting stuff down as soon as I see it. I see that there was a sample size of 129, and I see that that sample led to an average weight, which would have been a sample average of 206. And then it says standard deviation of the weight of, look, here's my word, all, standard deviation of all is known to be 18 pounds. That's what I got out of that first paragraph. You should see that and get that too. Okay, I want a 92% confidence level, so I'm going to go ahead and say that's going to be a 0.92, right? And it wants to determine the margin of error and the confidence interval. So I got to find everything this time. This is all they really give me. I got to find it all, okay? Now, if they gave me the confidence level, I can get all the way to the Z or the T-score. Which am I using? Well, because I know the population standard deviation, I'm going to use Z. But here I go with it. What do I need to know first? Well, I need alpha. Alpha is 1 minus that 0.92, so it's going to be 0.08, isn't it? And then I need alpha divided by 2, because with confidence levels, I always divide alpha by 2. And then I can get to my Z-score. Where's that table? I've got 0.04. I have to look up 0.04. As close as I'm getting here, I get 1.75 is what I'm seeing, right? Negative, I know, but we don't care. So I got a 1.75. I found Z. And now I want the confidence interval. Okay, did they give me the margin, determine the margin of error? Okay, so I got to find my margin of error for this thing. And my margin of error is going to be inside this confidence, it's going to be inside this formula. What is the confidence interval? Not CL, but CI, the confidence interval. Well, the confidence interval is equal to the sample mean plus or minus the Z-score times the standard deviation of X bar. Okay, look at that one. So they're not going to let me use the standard deviation that they gave me. They're going to make me make an adjustment. And you should see this right here on your sheet that I gave you. Every time I'm using these standard deviations, I'm having to adjust them. There will be a different formula for it every time, but every time. Now, it's not a hard adjustment. What do? I take the standard deviation and I divide it by the square root of the sample size. So the standard deviation of x bar for this one, I hope some of you are typing into your calculators as I speak. I got 5848. Go to 4 decimal places, round to 4 decimal places for all these standard deviations, and you should find the answers extremely close to the answers, if not exact, okay? Are we good so far? Now all I got to do is plug this in. And look, guys, this right here is the margin of error. You have that in your formula sheet. But what is the confidence interval? It's the sample mean plus or minus the margin of error. What's the margin of error? The z-score times the adjusted standard deviation. How does that look? I'll draw it. I'm only going to draw this one time, okay? What's the mean of this thing? What was it? 206? And what I'm looking for is inside here, this area has 92% of my data, doesn't it? Now, the margin of error, to get to these numbers, is going to be minus the margin of error. To get here is going to be plus the margin of error. I don't really care. Well, I do care what the z-score is. I know what the z-scores are now. I looked them up. Negative 1.75, positive 1.75. This is the number I'm interested in. That's how confident am I that the weight of these, that the average weight of the sample that I take of these alligators is going to be between these two numbers? I want to be 92% sure. That's what this is all about. Okay? 92%. That's my confidence. So how do I get it? Well, I go confidence interval is going to equal that 206. And I'm going to add and subtract the margin of error, which I'm going to calculate. It's going to be 1.75 times that standard deviation I just calculated, 1.5848. So I'll say, well, that's equal to 206 plus and minus, and I'll do this calculation and come up with my margin of error simply because they usually ask me for my margin of error, okay? And I got 2.77, said go to 2 decimal places, right? Is that right? So what's the confidence interval? The confidence interval is going to be, and I'll go and write it like they do in set notation. The low number is going to be 206 minus 2.77, which I ended up with 203.23. The high one is going to be 208.77, right? So that's what fills in these blanks, 203.23 and 208.77. So, in answer to their question, what's the margin of error? Well, the margin of error is 2.77 pounds, isn't it? It's always in the same units that we're dealing with. We're dealing with weight of alligators. So what does this show us? The same thing I just said to you a minute ago. I am 92% certain that the mean weight of the actual mean weight, the population mean weight, because that's what I'm trying to estimate. I'm always trying to estimate the population. I don't care what the sample does. I care about the population. But the only way I can figure out what it might be is to deal with a sample, okay? There's no way to weigh every alligator in the Everglades. The best I can do is weigh a sample and say, well, if the sample goes this way, then probably the population does. But what am I concerned with? I'm always concerned with population data. I'm telling you these things because that's another commonly missed question on the next test, okay? So what are we trying to estimate? We're always estimating population, okay? I'm confident, 92% confident, that the weight of those, actual average weight of all those alligators is going to be between 203.23 and 208.77. Does it make sense so far? Yes? Have you had a chance to view the videos for Chapter 7? If you haven't, this is not going to make sense. You have to see this several times for it to sink in. Believe me, when I first taught this for the first time, and I had had graduate statistics classes coming out my ears, when I first taught this for the first time, I had to go over it several times to understand it, to get a grip on it, okay? So expect yourself to have to do this several times to understand what problems you're dealing with. All right, let's do the next one. The Florida Department of Transportation wants an estimate of the average speed of vehicles on I-95. Well, that would be like 110, wouldn't it? The mean speed in miles per hour of a random sample of vehicles was found to be 84 miles per hour. Wow, surprising at that. Okay, so what have I got? I've got the average speed of that sample. Came out to be 84. The standard deviation of the speed of, look, all vehicles, so that's going to be the standard deviation of the population, is 7. Okay, so we are going to look at 3 different confidence intervals here because this is a conceptual question that you need to understand what happens when the sample size changes, all right? 3 different confidence intervals for a 95% confidence level. So what's my confidence level is always going to be? Let me just write it here. Confidence level is always going to be 0.95. And here's the different sample sizes. One's going to have a sample size of 60, one's going to have a sample size of 250, and one's going to have a sample size of 360. But if I know that the confidence level is always going to be 0.95, then I know that the z-score is always going to be whatever, okay? Z's not changing. Z is not based on sample size. Z is based on the confidence level. So let's go with alpha is equal to 0.05. And then we go alpha divided by 2 is equal to 0.025. And then we know that z is equal to, and we've already looked this one up a couple of times. I apologize because I used 95% in your examples too many times. But we know we've already looked it up. We look up that 0.0250 and we find it's 1.95, right? Or is it 6? Sorry, it's 6. Okay, 1.96. That's always going to be our z. So we're going to find these different confidence intervals, and then we'll answer these 2 questions. But here's where I'm going to do the work, okay? I'm going to kind of separate these right here. Wish I'd drawn lines for you. Okay, these are 3 different ends. So for this one, I'm going to say sample size is equal to 60. Now, I know z is always going to be 1.96, and I know that for that sample size of 60, I'm going to have a difference. What changes just because of the sample size? Well, it's this, the standard deviation of x bar. It's always divided by the square root of the sample size, right? So I start with my 7, which is always, that's the population standard deviation. This time I divide it by a square root of 60, and I come up with this number, 0.9037. So what is my confidence interval? The confidence interval is going to be the sample mean, which in this case doesn't change, it's 84, plus and minus the z-score, which doesn't change, it's 1.96, times the standard deviation that did change based on the sample size. This confidence interval came up to be 84 plus or minus 1.77, and that made a confidence interval of 82.23 to 85.77. All right, here's how it would look, right? I will only put on there these sample means is what I'll put. The middle one is the sample mean, the one we got. And it went from 82.33, let's go just further down here actually, 82.23 to 85.77. That's what it did, right? Margin of error is in here. Margin of error would be from here to here, would be 1.77, be plus 1.77. And to get here, I went minus 1.77. Okay, that's just so you can see what's happening. Next one, sample size change. The second one we got to do is n is equal to 250. So what are we going to change? Standard deviation. I've got to take my population standard deviation. This time I divide it by the square root of 250. And I came up with 0.4427. So that changed everything. My confidence interval is still equal to the sample mean, but it's plus or minus the same z-score, but this time the standard deviation is different. Changes the margin of error. Whoops, sorry. The margin of error is now 0.87. So the confidence interval is going to be, here it is, ranging from 83.13, 84.87. If I drew this down here, I'd say there's my center, 84. Over here, it's a little bit closer, isn't it? A little bit closer. 83.13, 84.87. What was the margin of error? Well, this would be plus my 0.87, and this would be minus my 0.87 to get there. You can see what's happening. As we go to a sample size of 360, what do you expect to happen? Do you expect these two numbers to get closer to the mean or to get further apart from the mean? Yeah, I would expect them to get closer because this sample size increased, didn't it, from 60 to 250, and they got closer to the mean. So let's see what happens when we go to 360. And I hope some of you are already catching this and you're going ahead and working. I've got that standard deviation of x bar. I'm going to take my population standard deviation, and this time I'm going to divide it by the square root of 360. And I got 0.3689. So confidence interval is going to be 84 plus or minus 1.96. Nothing's changing except for the sample size, so the only thing changing is that standard deviation. And it's going to be times this 0.3689, which does change the margin of error, doesn't it? And that margin of error looks like 0.72. So what is this confidence interval? Well, the low is going to be 0.83 what is it, 28? And the high is going to be 84.72. So over here I'd say x bar, the mean in the center is 84. Over here I'm going to go, that's going to be 83.28. And this one is going to be 84.72. What was the margin of error? Well, this was minus my 0.72, and this was plus my 0.72. As the sample size increases, leaving everything else the same, the margin of error does what? As the sample size got bigger, what happened to the margin of error? It got smaller. It's going to decrease. So, as the sample size increased, it got bigger. What happened to the width of that confidence interval? Did it get bigger? Did it increase, or did it decrease? It decreased also, didn't it? Those are your conceptual, you should understand that problems. Questions, okay? Everybody have time to finish that up? Good? It's a lot of writing, I know. I'll try not to do so much on the next pages. Okay, question 6. There's a marine biologist. He wants to estimate the mean lifespan of all Florida manatees. The mean lifespan of a random sample of 45 manatees was found to be 46 years. Okay, so he gave us the mean of the sample, didn't he? And it was 46. And he gave us the sample size, and it was 45. Hope I got those two right, didn't I? And then he says the standard deviation of the lifespan of, look at this one, all, standard deviation of all, is equal to 8. Okay, I've written down everything in that first paragraph. Now he wants to use a 95% confidence level. So I'm going to say confidence level is going to be 0.95. At this point, you should be able to tell me Z, right? I mean, this is giving me a population standard deviation, so I need the Z-score, don't I? You should be able to get it. And once again, I gave you the same one, and I'm really sorry. I should have done some changing on these, but I've gotten a rut. And we want the confidence interval. We'll use interval notation. I didn't even put a picture for you to draw because by now it should be getting pretty easy. Alpha is equal to 0.05. Alpha divided by 2 is equal to 0.025. And when you look it up, Z is equal to 1.96. We've done that one enough that I know it, okay? Right? Okay, I got Z. Confidence interval is equal to the sample mean plus or minus the Z-score times, oops, the standard deviation cannot be 8. It has to be adjusted. This is going to be 8 divided by the square root of 45. And that is going to be 1.1926. Don't forget to do that part, okay? So, what's my confidence interval? Well, let's find the margin of error. It's this part. Don't forget what you're doing. That's the margin of error, okay? Those two numbers multiplied together. Z times the standard deviation of x bar. When I multiplied those two numbers together, I got 2.34. Am I doing okay? They said interval notation, which means parentheses, comma in between, right? 46 minus 2.34 is going to be 43.66. 46 plus 2.34 should be 48.34. And that's the answer, right? You could put it on a graph if you wanted to because you've done it. We've done it now. Okay, now let's change gears. Suppose the population standard deviation is unknown. So we don't know the population standard deviation, but the marine biologist found the standard deviation of the lifespan of the sample was 10 years. So let's write down what we know. We got the sample mean, it's still 46. We got the sample size, it's still 45. We know the sample standard deviation is 10. Use S. Don't use anything. Use the right symbols, okay, so that you got this right. S is the sample standard deviation. So we know it, and we want a 95% confidence interval. But here's where it changes. This changes things for you guys. Because you don't know the population standard deviation, you must now use the t-table, okay? Not the z-table. Is 0.95. We still need, for the t-table, you really almost don't have to go through the alpha and alpha divided by 2 thing. Look at your t-table. It says, up here in the top, it gives you confidence interval percents, 95%. There's my column, right? Now, if it didn't give you one, you would be between 2 columns. And if it hit in between these 2 levels, hopefully they're not going to do that to you too much, or you can use the calculator to find it. And if you use the calculator, you do need to divide alpha by 2, and then you need something called degrees of freedom. Now, for degrees of freedom, put it right beside n, because when you know n, you know degrees of freedom. It's always n minus 1. So I'm going to go to my t-table, and I'm going to say I need a confidence level, a confidence interval of 95%, and I need degrees of freedom of 44. Well, here's degrees of freedom of 44, and I go over to where, like I said, ignore those bottom 2. Let's just work on this top column, or this top row, and I come up with 2.0154. It's no longer in 2 decimal places. T-scores are given to us in 4, okay? The tables don't work the same at all. So 2.0154 is my t-score. Now I know everything I need to know. Well, one thing I don't know. I still have to adjust the standard deviation. I take 10, I divide it by the square root of my sample size, which was 45, right? And 10 divided by the square root of 45, I do that one right? 1.4907. Okay? And now I'm going to say confidence interval. This time, I mean, if you doubt and you're wondering where these formulas are coming from, they're coming from your formula sheet, but I've also given them to you here. If you have the sample standard deviation, you use the t-table. You have to do that calculation for the standard deviation, and there's your confidence interval formula. It uses t instead of z. Well, it's not really hard. Didn't change too much. We still say 46, sample mean, plus or minus, and this time we say the t-score times that adjusted standard deviation. Very much the same. Okay, so this comes out to be 46 plus or minus. Now this is our margin of error, okay? It's still the same. It's still the margin of error. And when I did this one, I got 3. Hopefully I did that right. So I have a confidence interval of 46 minus 3, which would be 43. 46 plus 3, which would be 49, right? Okay? You good? All right, now they're going to get really mean to you right on this next problem, okay? So, this time they said that the normal resting heart rate for adults ranges from 60 to 100 beats per minute, and the doctor wants to estimate the average heart rate for one of his patients, and he tells his patients to measure his heart rate twice a day for a week, and then he gave us the measurements. And we're assuming that the heart rate, all the measurements are approximately normally distributed. That just tells us, that we're okay using the tables we use. And so we want the point estimate, which is the sample mean, and then we want the sample standard deviation. Now, we don't know this patient's population standard deviation. We can't take all of his heart rates and put them together. We only have the sample. We only have the sample. How are we going to get the standard deviation? Do you remember how to do it? It's in chapter 3, I think it was. It might have been 2. But it's way back there, isn't it? This is the only time I'm making you go back to something that you did in the beginning, and you have to use it. But you will have to do it. For this one, I've got to come up with a sample mean, which is not hard. I simply add all these heart rates together and divide by however many there are. How many samples? I counted them. There's 14. So he took 14 heart rates, right? So I can add them together and divide by 14, and I will have the sample mean. I've got to have the sample mean. And then I've got to have Z or T. Which table will I be using? Do you know the population standard deviation? Do you even know the sample standard deviation? But you can calculate it, right? Do you remember how? One of the ways that we've done it is we go into a list. I'm going to clear this one real quick. And we enter them. 103, 101, 101, 105, 101, 115, 107, 101, 109, 113, 110, 112, 108, 116. I think I got those right. I'd normally check them, but I'm going to go ahead and run the stats on it, okay? I'm going to go stat, and I'm going to go calc, and I'm going to go one variable statistics. I'm doing it quick because you know how to do it. List 1, there's no frequency list because this is not grouped data, is it? So what's the mean? Well, there it is, 107.28. I'm going to go to 4 decimal places with it, 107.2857. And look, there's the standard deviations. I want the sample one because this is a sample of data, right? So I say, okay, S is equal to 5.4268. I'm rounding to 4 decimal places. And I've got everything I need now. Now, if you don't have the graphing calculator, are you going to have to do this on a test? Yes, you will be doing it. So you need to go back to the formulas in that old chapter And remember, we're doing x squared and the sum of x squared, and we have to do that calculation with the square roots and all that, okay? So here it is, confidence interval. Now, well, let's do this. Standard deviation of x bar is going to take the standard deviation and divide it by the square root of the sample size, right? What was the sample size? 14. And I think I did that too, and I came out with 1.4504. Okay, so let's go down here, because now they've told me 98% confidence level. Well, I know I've got to have a t-score, don't I? But to get t-score, do I even need to do alpha and alpha divided by 2? I'm kind of okay without it, aren't I? I can just go and say, what's degrees of freedom? It's going to be 13. So I'm going to go to 13 on my t-table, and I'm going to go up here and I'm going to go 98%. Fortunately, I have that column. And I'm going to go to t-score of 2.6503. Everybody with me? So I'm going to say t is 2.6503. And now I've got everything else I need. Confidence interval is now equal to the sample mean, 107, let's round to 2 decimal places, 29, plus and minus the t-score of 2.6503 times the standard deviation of 1.4504, and then I'll have the confidence interval is equal to the sample mean plus and minus the margin of error, which is 3.84. Confidence interval equals the low number I got, 103.45, the high 111.13. That should be right. Okay, so when you don't have anything given to you, when you don't have the sample mean or the sample standard deviation, guys, they have to give you the actual data, and then you have to calculate. Got it? And the test problem will be there looking like that, but it won't be so many numbers that you can't do it with the formula if you don't have the graphing calculator. Any questions on this one? You guys look as tired as, did you guys ride bicycles this weekend too? Yeah, I'm very tired too. Okay, an economist needs to estimate the proportion of residents of Jensen Beach that have earned a college degree. Determine the most conservative estimate of the sample. Now listen, this one starts talking about proportion problems. These are proportion problems. Now, he wants to estimate the proportion, it sort of tells you right there, that have earned a college degree. And he said this, look at these words, most conservative estimate of the sample size. Most conservative estimate tells you this, you are going to set the proportion equal to 0.5. So if P is equal to 0.5, then Q is also equal to 0.5. That's like saying the sample mean is going to be right down the middle, half, okay? So that's most conservative, and I get that from here. That's how I got it. I'm going to limit the margin of error to within 0.05, so here's my margin of error. And I've got a 96% confidence interval. Okay, so confidence level is equal to 0.96. I need a z-score. Proportions always use z. Doesn't matter. I mean, proportions, you never have to worry if it's a t-table, okay? So I need a z-score, 0.96. I've got alpha is equal to 0.04. I've got to have alpha divided by 2. It's equal to 0.02. And therefore, I can find out what z is if alpha is equal to 0.02. Can't I? I'm going to find my z-table. It's here somewhere. And I'm going to go to 0.02. And remember, we're only using the negative side. And I'm right here. 0.02 is about, this is the closest I'm going to get. So I get 2.05. So I got a z of 2.05. And from then, it's just, can you find the proportion? Well, your formula for, the sample size. The formula size for a proportion is z squared times p times q divided by margin of error squared. The only difference in the proportion formula and the other one is, remember how this was the standard deviation? Now it's P times Q. Okay, and it was standard deviation squared, so now it's P times Q. So I'm going to say 2.05 squared times P times Q divided by 0.05 squared. And I get a sample size. This is the number I get, 420.25. Tell me how many people I need to sample. What's my sample size? Thank you. It is 421. We bump it up even though it would normally round down, because we can't sample a fourth of a person, and we have to have at least this many. That's the way it's worded. All right, we're doing good, right? Okay, I'm doing good. I have trouble remembering what time your class ends. I'm sorry, I do. 9. Psychologist wants to estimate the proportion of Americans that say the future of the nation is a significant source of stress for me. To help form an estimate, the psychologist randomly selected 800, found that 65% of the sample agreed that the future was a significant source of stress. Wants a 98% confidence level, wants to find the margin of error and a confidence interval for the true proportion. It's almost like saying we got a sample mean and we want to estimate what the population mean is going to be. Sample proportion equates to the sample mean. True proportion equates to the population mean, okay? Just proportion data. Go ahead and do this one. You can get everything you can written down on this, all right? You should be able to get at least some of this stuff without my help. There's one new formula that we haven't used. I'm going to put it up here for you, okay? It's on your formula sheet, but I'll put it up here. Don't just copy what I've got. Make sure you know how to do this, okay? I'm just putting it up here so you can check your work. Okay. Now, the only thing that we haven't hit before or talked about before is how do you calculate the standard deviation of the sample proportion for these problems. And what you do is you take p hat times q hat divided by n, and then you take the square root of that, which you're sort of familiar with because we've done something sort of like that, I believe, before in chapter 6 and 7, okay? So p hat times q hat divided by n, square root of that, and that's how I'm getting that standard deviation. That's it for changing it. The only thing that you're going to have to watch for is the sample proportion is, you treat it just like the sample mean, okay? That's fine. Put it there. Can you what? Yeah, come back at 11. Okay. Okay. So that's the only calculation that we really haven't hit, okay? Other than that, that's a proportion problem. Are you good? Yes? All right, you guys are doing good then. One more. I think I've just got one problem on this last page. It is, though, however, one where they gave me the actual data and they expect me to calculate the sample proportion and everything. So here it is. There's a bookstore at IRSC, and it wants to estimate the proportion of students who prefer electronic over printed textbooks. And they took a sample of 30 students and listed their preferences. So we want the point estimate, which is p hat, and the sample proportion and the sample standard deviation, and we want to do a 94% confidence level. We're going to have to determine all that and see what is it between, you know, how many people actually prefer ebooks over textbooks. Now, they could have asked the question the other way, how many students prefer textbooks over ebooks, and it would have changed your numbers. It would have changed everything. But the proportion they asked for is who prefer electronic books over printed. So here's how many I got. For ebooks, I count, and I say, I'm counting these, and I ended up, I can't remember what I ended up with. Has anybody counted it? 12. So there's 12 that prefer ebooks. And then when I look for hard copy, it's going to be the others, it's 18, right? I have a sample size of 30. Now that's everything that's in the table. I don't even need the table anymore, do I? That's everything that's in the table. And now I can calculate the sample proportion. I need p hat, don't I? The sample proportion is right here. It's the number that prefer ebooks over the total sample size. It's simple, isn't it? A proportion is a relationship of two numbers to each other. The number that prefer ebooks over the total sample size gives me the sample proportion of the one I'm interested in. And like I said, it could have been the other way. So p hat this way comes out to be, and let's do a, well, it's 0.4, isn't it? Now, if I know p hat, I know q hat, don't I? So you go ahead and write it down. What is q hat for this problem? Yeah, 1 minus 0.4, right? So I got all that, and I'm ready to kind of set this thing up. A 94% confidence level tells me it'll give me my z-score, won't it? 0.94. Alpha is now 0.06. Did I do that right? Alpha divided by 2, 0.03, and that's what I have to look up in the z-table. 0.03, as close as I can get. It's probably right over here. 1.88, looks like it. Sorry, can't see that. So I'm going to use z is equal to 1.88. All right. Now, the confidence interval still has to have one more thing that I haven't calculated. What have I not calculated to get this? Standard deviation. So I got to say, okay, standard deviation of a proportion, sorry. And now we wait. It is the worst possible place to put an off button is right under where you have to put your hand, okay? Is it back? Good. Okay, so here we go. That's going to be the square root of p hat times q hat divided by the sample size. And all of you can do that calculation. You can just stick it in your calculator under the radical. Just make sure everything's under the radical, which means you may have to use parentheses. And I got 0.0894. How am I doing? Good? Any of you punching numbers and checking me? Thank you. All right, so here I have the confidence interval is going to equal the sample proportion, which was 0.4, plus or minus the z-score of 1.88 times the standard deviation that we just calculated. Confidence interval, 0.4 plus or minus, and those two numbers multiplied together is my margin of error, isn't it? And I got 0.1681. So, here it is, two numbers, 2319 and 0.5681, and that's what I came up with. Now listen, what is it saying? That it's saying that we are, please be able to interpret, okay? We're 94% certain that between 23.19% and 56.18% of all students prefer ebooks to textbooks. I'm going to say it again, okay? I'm 94% certain that between 23%, I'm just rounding, and 57% prefer ebooks. Well, guys, that's a huge, I mean, what do I really know? Well, between 1/4 and over, I mean, that's a big gap, isn't it? Why is it so big? Because it's got a pretty big margin of error. That's where the plus or minus. What would I do if I said, that's really not narrowing it down for me enough? I need a smaller gap. I need a smaller margin of error. What would I do? Bigger sample size. If you increase the sample size, you could do this, right? You're going to decrease the margin. Remember the problems we did? Increase the sample size. You're going to decrease the margin of error, right? You're going to narrow it down more, and that's what you do. You try to take bigger and bigger samples. Now listen, this sample was 30. For a proportion problem, that is extremely small. Proportions are just inherent. They're laden with decimals. They've got so many decimals in them. One more caution let me give you about these proportion problems, okay? I'm taking all of these standard deviations to 4 decimal places, but I used to make all of my students take them to 6. If it was a proportion problem, are you listening? Because they wouldn't get close enough to the answer that was in the software. I mean, they would be close, but they wouldn't be close enough to get it. So if you find that you're hitting it wrong, take your standard deviation for proportion problems out 2 more decimal places, and it'll probably line up closer for you. Okay, I think I'm done. You guys, all right, any questions before we go today? Yeah. Am I doing the? I don't know. I will find out. Okay. Was that? Okay. It's a good question. I'll find out.